Hello friends, I welcome you in lecture number 4 on heat equation. In this lecture also we will discuss one question on heat equation which was asked in GTU Summer 2020 exam. We have seen the first case of heat equation in which the boundary conditions are that value of temperature is 0 at both the ends of the bar and initial condition is given by ux0 equal to fx, and we know that solution of heat equation del u by del t equal to c square times del square u by del x square satisfying these two boundary conditions, and this initial condition is given by u equal to sigma n equal to 1 to infinity bn times sin n pi x over L e to the power minus lambda n square time t, where lambda n is given by c n pi divided by L. N takes the values 1, 2, 3 and so on, and this bn are nothing but 2 divided by L integral from 0 to L fx sin n pi x divided by L integral with respect to x, and values of n are 1, 2, 3 and so on. So all we have to remember is that the solution of heat equation together with this type of boundary conditions and this initial condition is given by this formula, and in this formula we have to obtain values of bn and lambda n, and after calculating their values we will substitute them in this expression and we will be able to determine the temperature at any position x and at any time t. So this we have to remember for the solution of this type of problems. Here we are given to find out the solution of heat equation together with this initial condition and these two boundary conditions. So here it is clear that temperature is 0 at both the ends of the metal rod. Suppose this end is at x equal to 0, this is at x equal to L, then here length is denoted by small l. So it is given that value of temperature is 0 at both the ends of the given metal bar or metal rod, and temperature at time t equal to 0 is given by sin pi x divided by L. So we can mention these things, that length of the bar is denoted by small l, and this initial condition is giving us the function fx. So fx is sin pi x divided by L, and first we write down lambda n. Lambda n is given by c n pi divided by length of the bar. Here length of the bar is denoted by small l, so we write small l instead of capital L. N takes the values 1, 2, 3 and so on. And now we find out these coefficients bn. The formula is 2 divided by L integral from 0 to L f of x multiplied with sin n pi x over L integration with respect to x. Length of the bar is denoted by small l, so we replace capital L by small l. Function fx is sin pi x divided by L, that we write here sin pi into x divided by small l, and here also we replace length of the bar by small l integral with respect to x. So here I have 2 times sin into sin, so we can rewrite this by using this formula. We know that minus 2 sin alpha times sin beta is equal to cosine of addition of these two angles minus cosine of alpha minus beta. So here we can adjust this to write in this form. We take these 2 inside the integral and we multiply with -1 outside as well as inside the integral, so that we can write in this form -2 sin alpha sin beta. And here angle is n pi x by L, here angle is pi x by L. So I am writing in this way. I am writing this angle first, -2 sin n pi x by L times sin pi x divided by L integral with respect to x. And now we can apply this formula. First we have to take addition of these two angles, n pi x by L and pi x by L, and cosine of their addition, and minus cosine of subtraction of these two angles. So now I am writing that step. Here I can rewrite this as -1 divided by L integral from 0 to L. First I am taking addition of these two. I have to add n pi x by L with pi x by L. So this I can rewrite as n plus 1. In the denominator I have L and n pi x plus pi x. So we can take pi x common and we have n plus 1 times pi x. And if I have negative sign, here I will have n minus 1 times pi x by L. So first I am writing addition of two angles, that is n plus 1 pi x divided by L minus cosine of n minus 1 pi x divided by L, and then I have to integrate this with respect to x. Now we know that integration of cosine function is sine function, and here coefficient of x is n plus 1 pi divided by L. So integral of this function is sine of n plus 1 pi x divided by L, and I have to divide that quantity by n plus 1 times pi over L, and same thing here. So let me write that first here, sine of n plus 1 times pi x divided by L, and this I have to divide by coefficient of x, which is n plus 1 times pi divided by L, and here same thing with negative sign. Instead of n plus 1 I have to write n minus 1 pi into x divided by L. This I have to divide by n minus 1 pi divided by L, and limits of x are from 0 to small l. So here I am using the fact that integral of cos alpha x is given by sin alpha x divided by coefficient of x, which is alpha here. Here alpha is n plus 1 pi over L. Here alpha is n minus 1 pi divided by L. And here we can take this in the numerator. So if I rewrite this, you can see I can write one more step, L divided by n plus 1 times pi, and this is sine of n plus 1 pi x divided by L. Similarly, this is L divided by n minus 1 into pi, sine of n minus 1 pi x divided by L. So far we have not taken the values of x. Okay, we have just rewritten all these things. Now if you can see here, I can take L divided by pi common, so that L will get with this L, it will get cancelled, and I am left with 1 by pi. And here let me write sine n plus 1 pi x divided by n plus 1 minus sine of n minus 1 pi x divided by L. So I forgot to write this. Sine of, this is sine of n plus 1 times pi x divided by L, and in the denominator I have 1 over n plus 1 here, and sine of n plus 1 into pi x divided by L, and the same thing here, minus 1 over n minus 1 sine of n minus 1 times pi x divided by L. X is from 0 to L. Now here we have to be careful. We can see that here I have n minus 1 in the denominator, and for Bn value of n starts from n equal to 1 and so on. So this is undefined. This quantity 1 over n minus 1 is undefined if n is 1. So this is going to be valid for all values of n which are different from 1. For n equal to 1, we have to calculate Bn separately. And for rest of the positive integers, we can find out Bn from this expression. First we have to take x equal to L. Suppose I take x equal to L, then here we can see if I take x equal to L, I will have sine of n plus 1 into pi. This x equal to L will get cancelled with this L, and I have sine of n plus 1 into pi. Now n is positive integer, therefore n plus 1 is also positive integer, and therefore this is going to be 0. Same thing here. Here for x equal to L, we will have sine of n minus 1 into pi. Now n is an integer which is different from 1, and therefore n minus 1 is also an integer, and that is going to be 0, because if I have multiple of pi as integer, then sine is always 0. So this will be 0 for upper limit. Now for lower limit, we have to put x equal to 0. So if I put x equal to 0, we can see here we will have sine 0, and here also we will have sine 0, that becomes 0. So what we have obtained, value of Bn is 0 for all values of n except 1. So here I am writing n equal to 2, 3, 4 and so on. And for n equal to 1, I have to calculate Bn separately. So for that we can use this step directly. Suppose I give this, suppose I am giving this step, or I can use this step also. Suppose I give this number 1. Then for n equal to 1, I will take n equal to 1 everywhere in this equation. So here I have n equal to 1. So if I take n equal to 1 in this equation, I will have minus 2 sine pi x by L into sine pi x by L. That will be sine square pi x by L. And here we don't require negative sign, so we will keep 2 as it is. So for n equal to 1 in this equation, we will have B1 equal to 1 by L times 2 sine square pi x by L. So that I am writing here. Now for n equal to 1, we are calculating B1. So we will consider n equal to 1. Taking n equal to 1 in equation number 1, we obtain B1 equal to 1 divided by L integral from 0 to L 2 times square of sine of pi x by L integral with respect to x. So I am using this equation. Here I take n equal to 1. So this becomes sine pi x by L multiplied with sine pi x by L, that is sine square pi x by L, and I am writing minus 1 into minus 2 equal to 2 and 1 by L in the product. Now this is easy to integrate. We can use the formula that 2 sine square theta is 1 minus cos 2 theta. We have to double the angle, so this I can write as 1 minus cosine of double of this angle, that is 2 pi x divided by L, and then I have to integrate this with respect to x. So what is this integral? Integral of 1 with respect to x is x. Here integral is sine of 2 pi x divided by L, and in the division I will write multiple of x, which is 2 pi over L. Limits are from x equal to 0 to x equal to L. For upper limit I will take x equal to L. So suppose I take x equal to L, here I have x equal to L, and for x equal to L, this L will get cancelled and I will have sine 2 pi, and sine 2 pi is 0. Therefore this term is giving 0 contribution when we take x equal to L. When x equal to L, this will be sine 2 pi, and sine 2 pi is always 0. So for upper limit we will have L only, and for lower limit I have to take x equal to 0. So this is 0, and if I take x equal to 0 here, I will have sine 0. So this quantity becomes 0 when we take x equal to 0. So, and here L is length of the bar, that is always non-zero. Therefore value of b1 is 1. So what we have obtained, b1 is 1 and bn is 0 for all values of n except 1. So finally we can write down the solution. The solution of heat equation with given boundary conditions and initial condition is, so we are writing the formula uxt equal to sigma n equal to 1 to infinity bn sine of n pi x over L in e to the power minus lambda n square times t. But we know that bn is 0 for all values of n starting with 2, and we have only b1 non-zero. So this is going to be a finite series with only one non-zero term for n equal to 1. So if I take n equal to 1, I have sine pi x, length is denoted by small l, e raised to minus lambda 1 square into t, and lambda n is cn pi over L. So we can write down lambda 1 from this. Lambda n is cn pi over L, therefore lambda 1 is c into pi divided by L. So that we will substitute here. Lambda 1 is c into pi divided by L. Value of b1 is 1. So b1 is 1 into sine pi x divided by L e raised to minus lambda 1 is c pi over L whole square times t, and this is equal to, here I have sine, okay fine, pi x by L. So this is sine pi x divided by L e to the power minus c square pi square t divided by L square. So this is the solution of given heat equation which satisfies given boundary as well as initial condition. Suppose I take x equal to 0, then you can see u0t will be equal to sine 0. So that will become 0. If I take x equal to small l, here I will have x will get cancelled and I will have sine pi, which is 0. If I take this t equal to 0, then you can see I will have sine pi x by L into e raised to 0, that is 1. So we obtain ux0 equal to sine pi x by L, that was our initial condition. So this is the correct solution of given problem, and you can see it is very easy to find out the solution. All you have to remember is that solution is given by this formula and you have to calculate Bn. Now while calculating Bn, you can directly put limits from this step also. If you are sure that this is going to be 0 for upper as well as lower limit, then we can minimize these steps also. We can ignore these two steps, and from this step only we can directly write down that Bn is 0, n takes the values starting from 2, because if I take x equal to L here I will have sin n plus 1 into pi, that is 0. Same thing here, if I take x equal to L, I will have sin n minus 1 into pi, that is also 0. And for lower limit, if I take x equal to 0, I will have sin 0 minus sin 0, that is 0. So from this step directly I can write that Bn equal to 0 for all n starting with 2, and I have to calculate for n equal to 1 separately, so that I obtain as B1 equal to 1. And finally we are writing the non-zero part of this series corresponding to n equal to 1. So B1 is 1 and lambda 1 is c pi over L. So in this way we can easily answer this type of questions, and this is all about this session. I hope you like it. Thanks for watching.